An area model is used to find the probability of two events happening. So we're always going to be comparing two events. One is represented horizontally on the box and one is represented vertically on the box. So in this story, a recent survey, 30% of children want to buy an iPad. Meanwhile, 65% of children say they dislike vegetables. What is the probability that a randomly selected child selected at random wants to buy an iPad and dislikes vegetables? When I hear the word "and," it makes me think that the student has to be in both categories, iPad and dislike. So we're going to look for a zone on our chart where the probability shows that a student is in both, iPad and dislike. So let's fill in some information. Do they want to buy an iPad? Yes. That is 30% of the students. Do they want to buy an iPad? No. That would be 70% of the other students. In terms of vegetables, 65% say they dislike vegetables, which would mean the remaining 35 do not want vegetables. In terms of the chart, we're going to label each axis. So going horizontally might be if the student wants an iPad. We're going to represent that 30% of the people want an iPad. So if this is from 0 to 1, the middle would be 0.5 or 50%. So 0.3 might show where 30%. So the first 30% of students want an iPad. I'll shade that in. Then we can look at disliking vegetables going vertically. Dislike. And again, we're going to go from 0% to 100%. The middle would be 0.5, and we're going to mark where 65% is, or 0.65. Draw a line across, and the part that we shade is the zone that shows 65% of the people, the larger group. Looking at these groups, I can see where they overlap. This small overlap section is where people are in both. That would be your "and." They both want to buy an iPad and dislike vegetables. Then we're going to use area to figure out what that probability is. So out of a square that's 1 by 1, the probability is the size of this box. The length is 0.3 and the width is 0.65. So our probability would be length times width, or 0.3 times 0.65, which is equal to 0.195. Or if you wanted to write this as a percent, that would be 19.5%. Second example, Trident Chewing Gum claims that 55% of people chew gum. The U.S. Census found that 40% of people own at least one dog. What is the probability the person choosing at random owns a dog and does not chew gum? So the gum chewers, the U.S. Census found 55% of people chew gum. So 55% do chew gum, which means 45% do not. And in terms of owning a dog, 40% of people own a dog, which means 60% do not. So when we start making our chart, we're going to represent one direction for the gum chewers and one direction for the dog. However, marking the probabilities is different this time because we want to find that a person does own a dog, so that would be the 40%, 0 to 1, 0.5, 0.4 for 40%. The smaller section is 40%. But then the other direction would be that they do not chew gum, which means we have to choose the no section for gum, which is instead of 55%, it's the remaining 45%. So from 0 to 1, 0.5 in the middle, 45%, 0.45, and shade the smaller 45% zone. And again, the "and" would represent the overlapping part where they have the dog and they do not chew the gum. So this area model would help us find the probability by finding the area, the length times width. 0.45 times 0.40% equals 0.18 or 18%.